Hello, my name is Kapousouz, and today I will present the paper The Combination of Survey and Health App Data, Sharing Behavior, Quality Assessment, and Validation of Survey-Based Health Indicators. I would like to acknowledge my co-authors Christoph Buethner, Florian Kuss, Henning Silber, Bernd Wade, and Timothy Johnson. As the time goes, our world becomes more digital and technological skills and knowledge become more necessary. The field of survey methodology must continually adapt to these changes. Researchers have for years been interested in matching survey data with additional sources of data. Currently, the researchers have the opportunity to link survey data with data from smartphones, applications, and wearable technologies. Data linkage can be valuable because it can make available multiple types of additional information that cannot easily be collected from questionnaires. Also, it can reduce survey costs. Several studies have examined the validity of health self-reports using other data sources. This literature is vast as health is a common and important construct in multiple surveys and is often associated with social desirability bias due to question sensitivity, meaning that respondents may purposely not provide accurate information on health questions. However, there is limited research on linking survey data and data from health applications. Here are our three research questions. The first one is, who is willing to share additional health data? The second is, what measures are available in this additional data and how is their quality? And the third research question is, how can health app data be successfully used to validate survey-based health indicators? It is known that measurement error is associated with sensitive questions. However, social desirability bias decreases when self-administered questionnaires are used and also possibly when respondents may have entered the information of interest on their own smartphones for their own personal use. In addition, researchers always try to minimize respondent burden. It is possible in the future respondents may be asked to upload health data from their personal electronic devices instead of answering survey questions. The data were collected by GESIS in November and December of 2019 in Germany. They used a non-probability online access panel with a sample size of 3,136. The median duration of each interview was 13 minutes. The survey included either health app data, which was approximately 2/3 of the sample, or Twitter data, which was the remaining 1/3. Respondents received a health app data sharing request if they were using an iPhone or a Samsung. Specifically, health app linkage was requested from 1,024 respondents with an iPhone and 1,055 respondents from Samsung. However, in the analysis, we only include the iPhone data due to challenges in transforming Samsung data. As for the data donation process, the respondents were asked to download their health app data and upload their data via an online data sharing platform. Lastly, the study included an incentive experiment for data sharing. Respondents were randomly offered 0, 2.5, 5, or 10 euros. The first dependent variable was willingness to share Apple Health data from phone applications. The variable is binary and 0 indicates people who refuse to share health data and 1 shows people who agreed to share health data. We constructed the second dependent variable after we filtered only for respondents who were willing to share health data. It is also binary and indicated who actually uploaded their health data, where 0 indicates people who did not share their data and 1 represents people who did upload their data. Here is the table with the independent variables. As for health indicators, we have 4 variables. The variable health was measured by asking would you say your health is, and the response options vary from bad to excellent. Respondents were asked to report their height and weight in the survey. Then we calculated the body mass index. The respondents were asked to rate their athletic performance. And also, they had to report how many times they have been physically active for 30 minutes or more over the past week. As for the respondent characteristics, we have 5 indicators. Respondents had to rate their general ability to use smartphones. In addition, respondents were asked how concerned they were about their privacy. Also, there were various questions to assess their opinion about polls and surveys. We created an index variable based on 13 questions. The Chromebook Alpha is 0.85. Respondents were also asked to evaluate this particular survey. Lastly, the survey asked whether the respondents have accounts in different social media. We coded that the respondent has an account if they used it for at least several times per year. Then we created one variable measuring the number of social media accounts respondents have. The social media platforms were Facebook, Twitter, Instagram, LinkedIn, Pinterest, Xing, and Thumb. Respondents were offered a different incentive in order to share their health data. The incentive offered were 0, 2.5, 5, and 10 euros. The reference group is 2.5 euros. Lastly, we used gender, education, and age as control variables. Then we ran a logistic regression. Then we examine what is the quality of the additional health data. First, we examine the information the health data included. Also, we test the correlation between variables from the survey and information from the health data. The table shows the variables used from the survey data and the health data. We will report the overall correlation and then the correlation for respondents who have smartwatch and the ones who do not. Our third research question is, can health app data be successfully used to validate survey-based health indicators? The dependent variable is the average daily number of steps. Almost all the shared health data included information for number of steps. However, we calculated the average daily number of steps only for respondents who had information for at least 300 days. Then, we calculated the average daily number of steps for the last year. Here is a distribution of the dependent variable. As we can see, it is not normally distributed. Therefore, we will also report the results with logged average daily number of steps as the dependent variable. Here are the independent variables that we used. As for health indicators, we used health ratings, BMI, how they rate their athletic performance, and the number of times they have been physically active for at least 30 minutes within the past week. We also used demographic control variables such as gender, education, and age. Here are the results of the logistic regression regarding who is willing to share health data, and we will break it down. For both models, we will discuss the odds ratio. The pseudo R-square for willingness to share data is 8%, and for uploading the data is 16%. As for the health indicators, we only found a few significant relationships. Specifically, the self-report evaluation of respondents' health is a significant predictor of willingness to share health data, such that healthier people are more likely to share health data. BMI, athletic performance, and the number of days they have been active are not significant indicators of willingness to share health data or if they have actually uploaded the data. Although smartphone skills were not a significant indicator of willingness to share health data, it was a significant indicator of whether respondents actually uploaded health data. In addition, respondents who were concerned about their privacy were less willing to share health data and less likely to actually upload the data. There was not a significant effect of concerns with the privacy to the probability to upload data because people who were concerned about their privacy were less likely to be willing to share data in the first place. Even though their opinion about polls in general was not a significant indicator, respondents who enjoyed this particular survey were more likely to be willing to share the health data and to actually upload them. Lastly, we examined the social media presence. For each additional social media account respondents had, the odds of uploading the health data increased by 27%. However, there was not a significant effect on actually uploading the data. As for the incentive, the reference group was 2.5 euros. We can see that the odds of being willing to share health data decreased by 42% for respondents who were not offered any incentive compared to the respondents who were offered 2.5 euros. However, we cannot see a significant effect on uploading the data, possibly because they were not willing to share their data in the first place. There was no significant difference between the respondents who were offered 2.5 euros and those offered 5 or 10 euros. As for gender, the odds of being willing to share health data were 59% higher for men compared to women. Men are also more likely to upload the data. Education was a significant indicator such that educated people were less willing to share their health data, but they were more likely to actually upload the health data when agreeing to do so. Lastly, age was not a significant indicator in either model. The information contained in each dataset varied. The most common information found in almost all data were the number of steps. 92% of the data has information about kilometers. We had information about height and weight for about 72% of the respondents. Around half of the data included information about decibels. There was information about steps per minute and kilocalories for approximately 30% of the data. Lastly, we had information for minutes of exercise, heart rate, aerobic fitness, degrees Celsius, and blood glucose only for a few respondents. Here we can see the correlation between variables from the survey data and the health data. As expected, the correlation on height and weight is very high at 0.97. The correlation between athletic performance and number of steps is 0.33, whereas the correlation between the number of times the respondents were active for at least 30 minutes and the average steps taken was 0.32. Both correlations are moderate. The correlation between the number of steps and BMI was negative but not significant. As we can see, the correlation between height reported in the survey data and health data and weight on survey data and health data is high for everyone. However, the correlation between self-report of athletic performance and number of steps is low for respondents with smartwatch, whereas it is moderate for respondents without a smartwatch. The correlation between the number of days respondents have been active during the past week and number of steps is moderate for the respondents with a smartwatch and low for respondents without a smartwatch. The correlation for BMI and number of steps had somewhat surprising results because it is positive for those with a smartwatch and negative for those without a smartwatch. Currently, we are not sure how to explain this finding. However, we know that only 20 people had a smartwatch and possibly we would need more respondents in order to further explain these results. Here are the results on the research question asking if health app data can be successfully used to validate survey-based health indicators. The dependent variable is the average daily number of steps. The results for the two models, with the dependent variable being the average daily number of steps and the logged average daily number of steps, are very similar. None of the health predictors were significant indicators of the number of steps. As for demographic characteristics, men are more likely to have a higher number of steps compared to women. In summary, approximately 40% of the respondents were willing to share their data and 9% of the respondents actually uploaded the data. Currently, we cannot explain the difference and more research will be necessary. We were surprised to see that the health indicators generally do not predict willingness to upload health data or whether data was actually uploaded. As expected, concern for privacy prevented people from sharing the data. This is a valid concern in today's world. Taking into consideration that respondents were not affected by their opinion for surveys in general, but by this specific survey, it is more important than ever for researchers to build trust with respondents. In addition, researchers should be prepared to give an incentive to the respondents, even if it is a small one. The quality and quantity of health data varies. Health information can effectively validate survey data, such as height and weight. As for height, we would expect perfect correlation between the survey data and health. However, this was not the case. We assumed that the data on the survey would be less reliable due to social desirability bias. However, the correlation was very high. The number of steps is moderately correlated with survey health data, so the steps can also validate the survey data. Nonetheless, we believe there is a value for collecting health data for multiple reasons. Firstly, some common measures between the survey data and health data may be more accurate on the health data because there is no social desirability bias associated. Most importantly, this paper showed that health data might substitute only some of the data collected from this particular survey. Nonetheless, it provides more information for analysis purposes. In the future, we plan to expand our research and examine more constructs that may be identical. One of the limitations of the study is the dataset contains some missing values that reduce the final sample size of the models. We also have a limited number of health data that we analyzed. Thank you very much.